Now, conversions can take quite some time. Imagine running a Markov chain for tens or hundreds of thousands of iterations, and you're looking at days or even weeks of running a model. Because of that, researchers working within the Bayesian paradigm have tried to come up with ways of speeding up computations, reducing execution time. In the slides, I go over a couple of methods that can be used to speed up computations. One is integrating R with C++. As you may know, C++ is a very fast programming language. However, running C++ or learning C++ from scratch can be quite a challenging endeavor. Rcpp is a package that allows us to use chunks of C++ code and call it from R with relatively minimal C++ knowledge. So I include a series of codes in which I compare the performance of pure standard R against Rcpp for instance, estimating a Logit model. And you will see that convergence takes almost 6 times as much when we estimate a Logit model in R compared to the estimation in Rcpp. In addition, another way to further speed up computation is using cluster computing or high performance computing. Right? You can think of typically most research universities in the UK have some sort of cluster. In Exeter we have ESCA, but like pretty much most universities have cluster computing services. You can also use Amazon Cloud, and the key advantage of using cloud computing is parallelization. So MCMC problems are what's called embarrassingly parallel, meaning imagine you're running a model with 3 parallel chains. Well, it's natural to send, rather than running the model sequentially, meaning running the first chain, waiting until the first chain is finished, and then running the second chain, and then subsequently, you can simultaneously send different chains of your MCMC program to different cores. Now, you don't need cluster computing for parallelization. There are packages in R that can be used to parallelize tasks, including MCMC chains within your computer. But the key advantage of using cluster computing is that just the volume or the number of jobs that can be sent at the same time. So what I mean by this is, suppose you have a model with and you're running 3 parallel chains to estimate the model. Well, the typical desktop computer has 8 cores, which means that you can efficiently parallelize at most 2 jobs. And by jobs mean models you are estimating, say. Well, with cloud computing, you typically have hundreds of cores available, so you can simultaneously estimate tens or hundreds of models. In fact, I include in the accompanying materials, I include code for a Logit model using Rcpp and estimated using cloud computing. And what we find is that essentially running a model in, say, a Logit model using Rcpp in a cluster computing speeds up. So it takes essentially 13 times more when you estimate the model using R than when you estimate the model using Rcpp plus cluster computing. So the efficiency gains in terms of shortening execution time can be sizable. So I include a couple of codes so you can familiarize yourself with running MCMC within cluster computing.